Hello dear students, this is Dr. Niaz Mohammed. In this lecture I shall talk about molecules. So let's start the discussion. A molecule is a stable particle of a substance that can show an independent existence in nature. A molecule could be a single atom or group of atoms. The atoms present in a molecule usually have complete last or valence shells. Let's see some examples. The atomic number of helium is 2. It has 2 electrons in its valence shell. So it is stable and can exist freely or independently. Also, the atomic number of neon is 10 and its electronic configuration is 2,8. Again, the valence shell of neon is complete. So it is stable and can exist independently. Now, we can say both helium and neon are molecules. They can also be called monoatomic molecules, means molecules consisting only one atom. Let's see another example. A hydrogen atom has only one electron in its valence shell, so it is unstable and can't exist independently. Now, for gaining stability, atoms can share their valence shell electrons. For example, the two hydrogen atoms can share their 1 electron with each other. Over here, for the differentiation, the electron of one hydrogen atom is shown by a cross, while the electron of second hydrogen atom is shown by a dot. These shared electrons are counted with both the hydrogen atoms. So you see the left side hydrogen has 2 electrons now. The right side hydrogen also has 2 electrons. The last shell of both hydrogens is complete. So the two hydrogen atoms can exist freely in this combined form as H2 molecule. Similarly, a fluorine atom with an electronic configuration of 2,7 is unstable and can't exist freely. To complete the valence shell, fluorine atom needs one more electron. So the two fluorine atoms share 1 valence electron to complete their valence shells and thus become stable in form of F2 molecule, which can show independent existence. Now, let's consider the example of H2O molecule consisting 2 hydrogen atoms and 1 oxygen atom. Individually, the 2 hydrogen atoms and 1 oxygen atom are unstable due to their incomplete last or valence shells. However, for stability, sharing of electrons occur between hydrogen and oxygen atoms, as you can see over here. After sharing of electrons, each hydrogen atom has 2 electrons in the last shell, while oxygen atom has 8 electrons in the last shell. So these 2 hydrogen atoms and 1 oxygen atom exist together and form H2O molecule that can show independent existence. Now, some more points about molecules. If a molecule consists of only one type of atoms, then it represents an element. For example, He, Ne, H2, O2, N2, P4 and S8 are the molecules of different elements. He is a molecule representing helium element. Ne represents neon element. H2 is a molecule representing hydrogen. O2 represents oxygen and N2 represents nitrogen element. Also, P4 is a molecule representing phosphorus while S8 represents sulfur element. Now these molecules consisting same type of atoms are also called homoatomic molecules. The number of atoms present in one molecule of these elements is called atomicity. For example, the atomicity of helium and neon is 1 because both of these molecules have one atom per molecule. Both helium and neon are also called monoatomic molecules, means molecules consisting one atom. Similarly, the atomicity of O2 and N2 2 is 2 is these molecules have 2 atoms per molecule. They are also called diatomic molecules. The atomicity of ozone is 3 is its one molecule consists of 3 oxygen atoms. It is a triatomic molecule. Now, molecules with atomicity more than 3 are usually called polyatomic molecules. For example, phosphorus and sulfur can be considered as polyatomic molecules. The atomicity of phosphorus is 4 as its one molecule has 4 atoms. Also, the atomicity of sulfur molecule is 8 as its one molecule consists of 8 sulfur atoms. Remember, sometimes the atomicity of molecules representing an element is not known because an indefinite number of atoms are present in one molecule. For example, carbon. Such molecules consisting large number of atoms per molecule are called macromolecules. Now, if a molecule consists of different types of atoms, it represents a covalent compound. For example, H2O is a molecule consisting 2 hydrogen atoms and 1 oxygen atom and represents water. Also, CO2 molecule representing carbon dioxide gas consists of 1 carbon atom and 2 oxygen atoms. Similarly, NH3 molecule representing ammonia gas consists of 1 nitrogen atom and 3 hydrogen atoms. Now, the 3 molecules I discussed over here, that is H2O, CO2 and NH3, are also called heteroatomic molecules, as these molecules are made up of different types of atoms. The atoms present in these molecules share their valence electrons and become stable in combined form. Remember, in addition to sharing of electrons, sometimes atoms gain stability by loss and gain of electrons as well. Let's see the example of sodium chloride or NaCl. The atomic number of sodium is 11 and its electronic configuration is 281. For stability, sodium atom loses 1 electron and forms sodium 1 plus ion with a stable electronic configuration of 28. Also, the atomic number of chlorine is 17 and its electronic configuration is 287. For stability, chlorine atom gains 1 electron and form chloride 1 minus ion with a stable electronic configuration of 288. The positively charged sodium ions and negatively charged chloride ions strongly attract each other and are arranged in a regular pattern in 3-dimensional space to form the crystal structure of sodium chloride. Now, this ionic compound or sodium chloride is represented by NaCl. The ion pair representing an ionic compound is called a formula unit. For example, the formula unit of sodium chloride is NaCl. Also, the formula unit of calcium oxide is CaO. The formula unit of magnesium fluoride is MgF2 and the formula unit of potassium oxide is K2O. Remember, a molecule represents an element or a covalent compound and can exist independently in nature, while a formula unit represents an ionic compound and can't exist independently in nature. Now guys, let's define the terms relative molecular mass and relative formula mass. First, the relative molecular mass. It is the mass of a molecule of an element or covalent compound relative to 1/12th part of carbon 12. For example, the relative molecular mass of hydrogen gas or H2 is 2. Means a molecule of H2 is 2 times heavier than 1/12th part of carbon 12. Also, the relative molecular mass of H2O is 18, means a molecule of H2O is 18 times heavier than 1/12th part of carbon 12. And now let's define the term relative formula mass. It is the mass of one formula unit of an ionic compound relative to 1/12th part of carbon 12. For example, the relative formula mass of sodium chloride or NaCl is 58.5. Means one formula unit of NaCl is 58.5 times heavier than 1/12th part of carbon 12. Also, the relative formula mass of calcium oxide or CaO is 56. Now, the relative molecular mass can be calculated by simply adding the relative atomic masses of all atoms present in one molecule of an element or a covalent compound. Similarly, the relative formula mass can be calculated by adding the relative atomic masses of all atoms present in one formula unit of an ionic compound. So, to calculate the relative molecular mass or relative formula mass, we need to know the relative atomic masses, which we can see from periodic table. And secondly, we should know the exact number of atoms of different elements present in a molecule or in a formula unit. Let's see some examples. The molecular formula for water is H2O. Now, the 2 written as a subscript with hydrogen in the formula shows that there are 2 hydrogen atoms in one molecule of water. Also, 1 oxygen atom is present in a molecule of H2O. Another example, the molecular formula of ammonia is NH3. The formula shows that one molecule of ammonia has 1 nitrogen atom. Also, the subscript 3 written with hydrogen shows that there are 3 hydrogen atoms in one molecule of NH3. Similarly, the molecular formula of hydrogen peroxide is H2O2. The subscripts 2 with hydrogen and oxygen means that there are 2 hydrogen atoms and 2 oxygen atoms in one molecule of hydrogen peroxide. Also, the molecular formula of glucose is C6H12O6. The formula shows that there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms present in one molecule of glucose. Now, let's see the number of atoms in some formula units of different ionic compounds. The formula unit of sodium nitrate is NaNO3. The formula shows that 1 sodium, 1 nitrogen and 3 oxygen atoms are present in one formula unit of NaNO3. Also, the formula unit of ammonium nitrate is NH4NO3. Now here we have 2 nitrogen atoms, 4 hydrogen atoms and 3 oxygen atoms in one formula unit of ammonium nitrate. Similarly, the formula unit of aluminium sulfate is Al2SO4 whole thrice. In the formula, the SO4 is enclosed in a bracket. The number 3 is written as a subscript outside the bracket. It means the 3 has to be multiplied both with sulfur and oxygen. Now, there are 2 aluminium atoms, 3 sulfur atoms and 12 oxygen atoms present in one formula unit of aluminium sulfate. Okay guys, now let's see some examples for relative molecular mass and relative formula mass calculations. An oxygen molecule has 2 oxygen atoms. The relative atomic mass of oxygen is 16. So 16 into 2 is equal to 32. That is the relative molecular mass of oxygen or O2. Also, a molecule of phosphorus, that is P4, has 4 phosphorus atoms. The relative atomic mass of phosphorus atom is 31. So 31 into 4 is equal to 124. That is the relative molecular mass of P4. Let's see another example. A molecule of ammonia gas is represented by NH3, means one molecule of ammonia has one nitrogen atom and 3 hydrogen atoms. The relative atomic mass of nitrogen is 14 and the relative atomic mass of hydrogen is 1. So for nitrogen it is 14 into 1 is equal to 14, and for hydrogen it is 1 into 3 is equal to 3. Now if we add these two numbers, we get molecular mass of ammonia, that is 17. Another example, a molecule of perchloric acid, that is HClO4, has one atom of hydrogen, one atom of chlorine and 4 atoms of oxygen. The relative atomic mass of hydrogen is 1. The relative atomic mass of chlorine is 35.5 and the relative atomic mass of oxygen is 16. Now for hydrogen we shall write 1 into 1 is equal to 1. For chlorine we shall write 35.5 into 1 is equal to 35.5, and for oxygen we shall write 16 into 4 is equal to 64. Now if we add these three numbers, we get 100.5, that is the relative molecular mass of HClO4. Another example, a molecule of carbonic acid or H2CO3 has 2 hydrogen atoms, 1 carbon atom and 3 oxygen atoms. The relative atomic mass of hydrogen is 1. The relative atomic mass of carbon is 12 and the relative atomic mass of oxygen is 16. For hydrogen we shall write 1 into 2 is equal to 2. For carbon we shall write 12 into 1 is equal to 12, and for oxygen we shall write 16 into 3 is equal to 48. Again, if we add these three numbers, we get 62, which is the relative molecular mass of carbonic acid. Now let's see some examples for relative formula mass calculation. A formula unit of sodium chloride has 1 sodium ion and 1 chloride ion. The relative atomic mass of sodium is 23 and the relative atomic mass of chlorine is 35.5. So for sodium we shall write 23 into 1 is equal to 23, and for chlorine we shall write 35.5 into 1 is equal to 35.5. Now if we add these two numbers, we get 58.5, that is the relative formula mass of sodium chloride. Now let's take the example of sodium carbonate. The formula unit of sodium carbonate is Na2CO3. It has 2 sodium atoms, 1 carbon and 3 oxygen atoms. The relative atomic mass of sodium is 23, the relative atomic mass of carbon is 12 and the relative atomic mass of oxygen is 16. Now for sodium we write 23 into 2 is equal to 46. For carbon we write 12 into 1 is equal to 12, and for oxygen we write 16 into 3 is equal to 48. If we add these three numbers, we get 106, that is the relative formula mass of sodium carbonate. Okay, another example, let's consider aluminium sulfate. Its formula unit is Al2SO4 whole thrice. So we have 2 aluminium atoms, 3 sulfur atoms and 12 oxygen atoms in one formula unit of aluminium sulfate. The relative atomic mass of aluminium is 27, the relative atomic mass of sulfur is 32 and the relative atomic mass of oxygen is 16. Now for aluminium we write 27 into 2 is equal to 54. For sulfur we write 32 into 3 is equal to 96, and for oxygen we write 16 into 12 is equal to 192. Now if we add these three numbers, we get 342, that is the relative formula mass of aluminium sulfate. Now let's see how do we calculate the relative formula mass of hydrated salts. Let's take the example of hydrated sodium carbonate. Its formula is Na2CO3.10H2O. This hydrated compound has 2 sodium, 1 carbon, 3 oxygen atoms and 10 water molecules. The relative atomic mass of sodium is 23. The relative atomic mass of carbon is 12. The relative atomic mass of oxygen is 16 and the relative atomic mass of hydrogen is 1. Now for sodium we write 23 into 2 is equal to 46. For carbon we write 12 into 1 is equal to 12. For oxygen we write 16 into 3 is equal to 48. Now there are 10 H2O molecules. The relative molecular mass of H2O is 18. So 18 into 10 is equal to 180. Now if we add these 4 numbers we get 286. That is the relative formula mass of hydrated sodium carbonate or Na2CO3.10H2O. Now guys, pause the video and try to find the relative molecular or relative formula masses of following compounds. If your answers are like these, then it means your calculations are correct. And now summary of the lecture. A molecule is an atom or a group of atoms that can show independent existence in nature. Homoatomic molecules are made up of same type of atoms and represent elements. Heteroatomic molecules are made up of different types of atoms and represent covalent compounds. Atomicity is the number of atoms present in a molecule. Relative molecular mass is the mass of a molecule relative to 1/12th part of carbon 12. Relative molecular mass can be calculated by adding relative atomic masses of all atoms present in a molecule. A formula unit is an ion pair representing an ionic compound. A formula unit cannot show independent existence in nature. Relative formula mass is the mass of a formula unit relative to 1/12th part of carbon 12. Relative formula mass can be calculated by adding relative atomic masses of all atoms present in a formula unit. And thank you so much for watching this lecture. See you next time with a new topic, and for that please do subscribe my channel.